So we're on 12. So once again, thank everyone for coming and connecting into this tech talk, which is going to be delivered this week by Stephen Lane of Capula. Steve is a cyber lead, and he's kindly developed these slides, which he's going to deliver on cybersecurity in an uncertain world. We are recording, so could I kindly ask you guys to go on mute unless you've got a question? Feel free to raise your hand and jump in, or put something in the chat. There will be a Q&A session at the end for any questions as well. So yeah, over to you, Stephen. Take it away.
Okay. Yeah, thank you. Yeah, so as Chris said, what we're going to talk about really is about how do we secure our industrial control and operational technology in what is increasingly an uncertain world. So just very quickly, as Chris said, I am the OT cyber lead at Capula. For those of you who don't know who Capula are, we are a system integrator, primarily a engineering company delivering panels and industrial control systems. But that's our core business. We're a subsidiary as well of EDF. We've been around a little while. We've been around 50 years. And I guess we are one of the sort of leading system integrators. Off the side of that, because our clients were asking for it, we've built a cybersecurity specialist practice, and that practice is just around operational technology. We really don't do anything else other than operational technology and cyber of operational technology. And I think I'd like to distinguish us between the likes of other technology companies that do the IT side of things, with us being that we are actually deep specialists really in the OT cyberspace. So what we're going to talk about, by the way, and I promise today is not a marketing, this is a technical deep dive. So this is not a marketing presentation. Not here to try to sell you anything, but hopefully to give you some background and best practices, and to think about how you can go about securing your environments, as well as how big is the problem. And that really is the nice segue to the agenda. So we're talking today about OT ICS risks. We're going to bring it up into context with the strategic defense review that came out that mentions critical national infrastructure, talk about some of the threat actors that we face. We are living in a world of grey war, and so we need to talk about what is that grey war and what is it overall. April 25, of course, we saw the Iberia Peninsula outage, which wasn't a cyber attack as far as we know, but is a really interesting case study. We're going to talk about real mail and a ransomware attack on OT, which is a good case study for lots of reasons. It's out in the public domain, but also as well, I happen to be on the cyber response team, and so I know it quite well. We're also going to talk really then about how we go solving the problem. And one thing that we have done here in Capula is try to think about how we solve the problem by distilling it down into simplicity. I think one of the challenges at the moment is that a lot of the things, when you talk about sort of like the cybersecurity standard 62443, and when you talk about other cybersecurity standards, is they seem to be very complex. And we've boiled it down to something that I think is much easier to wrap your head around about how you go about fixing things. So let's jump into it, and let's talk about cybersecurity threats in the current geopolitical climate, and let's do a threat briefing. All of the stuff that I've got in this is public domain. You can go and research it. And what I've fundamentally done is I've aggregated the threat intelligence from Dragos, from Clarity, from Nozomi, Radiflow, and also as well from government organizations such as the NCSC, and in the US, the CISA. And if we just contextualize, operational technology and industrial control systems are the backbone of our society. There's so much that relies on it. When we wake up in the morning, we get out of bed, we turn the tap on, we brush our teeth, we go down, turn the kettle on, kind of thing. what we're probably not realizing is just how much industrial control systems are behind that and our actions. And I think one of the things that was really interesting in the Iberian incident is just how society started to break down. It started to break down really, really quickly. But these systems are under increasingly threat. They are increasingly under threat. They are targeted by cyber criminals. They're targeted by state-backed actors. We're going to talk and bring this into context with the 2025 Strategic Defence Review, which talks about cyber attacks. And I think this is probably the first time I've seen a government strategic defence review highlighting and flagging up critical national infrastructure. And overall, we're going to talk about recent campaigns by cyber criminals, by hacktivists, and by nation states' advanced persistent threats. And you'll hear me call those APTs if you're not familiar with that jargon, but fundamentally the most sophisticated threats out there are known as advanced persistent threats, APTs, the most dangerous as well. And key examples we're going to talk about, we cannot talk about this without talking about the Russian and Ukrainian war, and we can't therefore talk about this really without talking about the Ukrainian grid attacks. And as I said, we're also going to think about, as a bit of a thought experiment, what if the Iberian Peninsula blackout had been a cyber attack? Because I think it's almost like a stress test of what would happen. So let's jump into this. The first thing is, let's contextualize this overall with escalating threats to critical infrastructure and the Strategic Defence Review that came out. The 2025 Strategic Defence Review, pretty much hot off the press, ink only just dry. It urges a pivot to a new way of war, and it emphasizes cyber and digital resilience. Military and intelligence leaders are calling for us to be on a war footing in cyberspace as hostile actors increasingly are probing vital UK systems. And the thing is, I've never seen the threats change so fast in my entire career, which is now very long given my grey beard. The reality is that pace of change of threat is increasing. And that's been very much accelerated by the Russian invasion of Ukraine. There's been a surge in hostile cyber activity targeting energy, communications, and other critical services across Ukraine and also across NATO nations. We can go back to 2023 when the NCSC warned of Russian-aligned groups targeting Western CNI. So it's not entirely new, but it is definitely escalating. And we'll talk a little bit around the hacktivists and go dig into that a little bit more about how these have become serious risks and how, in fact, hacktivists are, in a lot of cases, proxies for government organizations to just live really under that threshold of what a cyber war would be that would trigger a response by NATO organizations. And in 2023, the UK, US, Canada, and Australia issued a joint advisory on Chinese state hackers. So it's not just us worrying really about Russia, which is a very significant threat, but also as well some wider threats, and we'll dig into that. We've got a bit of a slide around that as well. But this, when we talk about hybrid war, this is hybrid war in action. Geopolitical tension and regional conflicts are turning critical infrastructure into strategic targets. And in response, the UK Cyber Strategy and Integrated Review prioritises resilience in CNI, and NATO allies are generally strengthening defences across energy, transport and industrial platforms. And there's a very clear message. OT and ICS are now part of the modern battle space. So if you are working in operational technology and you're working in industrial control systems, we've got a big problem that we need to think about. And I think it's highlighted on this slide. One of the things out of the defence review is that it says that many operators just don't have the ability at the moment to protect the infrastructure they own in the face of such complex and evolving threats. So that's the first sort of slide that contextualizes where we are at in the world of geopolitics at the moment. So the other thing as well is that OT systems are no longer niche or isolated. They are very much prime targets for cyber adversaries. At one point, we don't have to go back too long, actually, where operational technology, industrial control systems, legacy systems was isolated and was not at all connected. And we really didn't think about it as something that would be a target. It was also as well specialist in knowledge. When the very first attacks came out, such as Stuxnet, we'll talk about in a moment, people generally didn't have a huge amount of knowledge about these industrial control systems, except for the engineering communities, and they were not necessarily thinking about cyber. So Dragos produces quite a really good comprehensive report on a year-on-year basis, and you'll hear me reference that throughout. It talks about the fact that it's become mainstream. Targeting OT has become mainstream for threat actors. And even the most basic of tactics can yield disruptive results. And I've got a good slide coming up that will give you an example of that. Staggeringly as well, we saw an 87% year-on-year increase on ransomware attacks on industrial systems, which is quite staggering. And the sector that was hit the most was manufacturing, which was 70% really of victims. And that's fundamentally because there is a bit of a weaker cyber maturity in that space. It's not a regulated industry, and I find that when I talk to people in FMCG that means there's less investment gone into OT cyber, but also as well the costly nature of downtime is significant, because if you stop manufacturing, you stop product going out the door, you stop revenue. And in fact, take a look at what's happened with Marks and Spencer. That's been a very significant attack. Threat actors that once targeted IT systems are now very much pivoting towards OT for greater leverage, because they know it's much more painful. The other thing as well, and we'll get into this in a moment, is that we're seeing very much more purpose-built industrial control systems, malware, and that's becoming more sophisticated. So we'll go into that. But all of this as well is around the fact that there is an expanding attack surface. We've got industrial control systems that I would consider to be hyper-connected. We have still OT devices that lack even basic cyber protections. We don't have authentication of them. There's no secure protocols and so forth. And if you look at 2023, a statistic that I picked up on, there were 134 ICS advisories covering 842 vulnerabilities issued by the US organization, the CISA. And many of these flaws affect core infrastructure sectors like energy, water, and manufacturing. So, what are we seeing here? We're seeing that the OT threat landscape today is defined by more frequent attacks, greater sophistication, a wider spectrum of adversaries of criminal, state, and hacktivists, and much more capable attack tools. All of that set against a backdrop of aging infrastructure, under-segmented networks, and I see that time and time again. I see flat networks, not even segmented from the business. We see that. And we also see inconsistent monitoring. And it's quite remarkable how much of the world is dark to cyber threat. There is no monitoring and no capability of identifying cyber threats in the networks. So let's talk really about ICS and OT malware. And this timeline here, it charts the evolution of malware targeting industrial control systems from 2010 to 2024. And it illustrates a clear shift. It started really with espionage and proof of concept sabotage to real-world destructive operations, including by non-state actors. And each example really demonstrates how adversaries are gaining access to systems that control critical infrastructure and in some cases deliberately disrupting them. There's some key milestones rather than going through each of these individual ones that you can read on the slide. 2010 and 2015 was the foundation of ICS attacks. My career, in fact, in industrial control systems started just before Stuxnet, and I was trained in defending OT cyber systems by people that I've often wondered, did they know that Stuxnet was actually going to come out? Which I'm never going to know the answer to that, but I've always wondered. But we see initially a foundation, an experimentation, and these are characterized by specific pieces of malware that are written for a single target overall. They're not necessarily modular. They're also very expensive. I forget the number of how much it cost to develop Stuxnet, but it was in the billions of dollars. It was a big number. So very, very expensive. 2016 to 2018 saw a purpose-built disruption, and we started to see modularity. So Destroyer built a modular framework that used industrial protocols to directly manipulate power systems in Kiev. We also saw attacks on safety systems with the whole purpose of causing physical harm to individuals with Trisis at the Saudi petrochemical plant. That fortunately didn't cause injury or death, but it could have. And that's quite scary as well. This crossover really between the cyber world and the safety world is right there back in 2017. Also as well, there was the Grey Energy campaign from 2015 to 2018, which focused on stealthy access and preparation, likely as a staging tool for future ICS sabotage. 2020 to 2022 was a convergence of crime and state level capability. We saw the Ekans ransomware that killed ICS related processes, and if I remember rightly, it hit Honda, and before encrypting files. And it demonstrates that this domain is not just dominated by state actors, but we actually don't know who developed the Ekans ransomware, but it was developed by a criminal group. And the next thing I think that was developed as well was Pipedream, which has been called the Swiss Army of ICS attack toolkit. It's never been deployed because it was discovered and made public before anybody was able to use the capability of it. But it was designed for broad-scale system disruption. It was also designed so that you could add modules into it. So if you had a particular target that you wished to attack, you could add specific protocols, for example, into Pipedream. And that's a big step forward as well. And then we've got to talk about 2023, 2024, hacktivists and offensive use by non-state actors, such as Cosmic Energy, Frosty Goop, and very recently, a derivative, I guess, of Stuxnet is this Stuxnet as well, which is pro-Ukraine Blackjack Group, which is a hacktivist group, but very state-aligned, where they disrupted over 87,000 sensors in Moscow by targeting an M-bus infrastructure. So let's take a look at some of this from an analysis perspective. ICS malware is no longer exclusive to nation-state actors. Groups like Blackjack are building and deploying destructive ICS malware with focused but very effective impact. And the trend is towards simplicity. We started off by having very expensive software to develop that was very targeted against a single system. And now, actually, most of the recent attacks are using well-known protocols. They're modular. They're using things like Modbus, IEC 104, and basic infrastructure exposure. They're much simpler to use. They're much more modular. It's becoming commoditized fundamentally. It also means that the people who are carrying out the attacks need to have less skills themselves to be able to carry it out. And my worry is that this kind of stuff, this kind of technology will get into the hands of very unsophisticated back bedroom teenagers, often known as script kiddies, because I think that that is probably the trajectory we're on. And we also as well need to highlight that originally tools like cosmic energy were developed for red teaming. They were developed for testing systems. These have now been discovered out in the wild. So even training tools have become a risk if they've been leaked or misused. So as a closing thing on this slide, the timeline makes one thing really clear, that ICS threats have evolved from rare and high complexity attacks to widely accessible and operationally deployed malware. We're seeing adversaries across the spectrum. We're seeing nation states, cyber criminals, and ideologically driven groups use cyber tools to threaten our physical infrastructure. And jumping into APTs, advanced persistent threats, we can pretty much see the axis between those that are threatening us and are hostile to the Western world and the threat groups. And the one that I always highlight is Sandworm, which is the Russian GRU, and known now as Advanced Persistent Threat 44. These APTs are given numbers. So APT 44, it's become very sophisticated, very capable, and it actually was responsible for the first ever cyber-induced blackout in 2015. But when I say sophisticated and capable, one of the things we're going to look at is we're going to look at tools, techniques, and procedures of Sandworm, and you'll see that we only have to do the basics to make their life difficult, and we'll talk about it in a moment. I'm also going to highlight as well in Iran. So we have APTs like APT 33, 34, which are state-aligned and state actors, but we also have very active and probably state-sponsored hacktivists known as Bauxite or Cyber Avengers. And I've got a good example of some of the things that they've carried out and everything, but they exploited devices in 2023, and we'll look at that as well. So the Israeli situation with Gaza is adding to the overall stress. We are seeing, hacktivists, and we're seeing Iran as well being involved in that, involved in sort of the grey war. North Korea is emerging as an ICS threat. They are primarily focused on financial cybercrime because of their sanctions, but they are probing ICS systems too. We've seen that, and we've seen the Lazarus Group and Coverlight showed interest in energy targets. In 2021 as well, those guys attempted an intrusion into an Israeli water facility. So these guys are the headline grabbers. They are the most capable and persistent ICS attackers, and their attacks can lead to widespread outages, safety system disablement as well, and long-term damage, especially where it supports their geopolitical aims. Their focus is very much not opportunistic, it's strategic. And one of the things that we'll talk about in a moment is that some of these state actors are pre-positioning insofar as that they are gaining a foothold into our industrial control systems, but they are not acting. And we can see an example of that with China's Volt Typhoon attack. So, so let's also talk about ransomware threats to industrial control systems. Over the last few years, we've seen very significant financially motivated ransomware groups. These guys, they used to target IT, but they're now increasingly targeting ICS, and sometimes unintentionally. but their actions often result in unplanned shutdowns of industrial processes. The motivation behind them is definitely profit and not politics, but the collateral damage from this can be significant. And some of the examples that have been out there, which you may have heard of before, is the Colonial Pipeline shutdown, which was one of the most most well-known ransomware incidents. The ransomware group was DarkSide. They compromised the IT systems, but that led to the shutdown of the pipeline because of the fact that they were concerned about malware propagating into that environment. That resulted in fuel shortages, panic buying across a number of US states. And although, and this is just a good example of, although the OT wasn't directly hit, the response to the IT breach just had a serious knock-on effect with OT. So when we're thinking about securing our OT environment, we can't think just about OT in isolation. We've also got to think about our IT as well. We also, JBS, which is the world's largest meat processor, in 2021 was hit with ransomware. It shut down facilities in the US, Canada, and Australia, and that directly affected food production and supply chains. And that illustrates how ransomware on enterprise systems can ripple as well into the ICS heavy operations, again targeting IT, but it had an effect. It also has a physical effect in the world because it affects food chains, and boy do we know that right now with the likes of Co-op and Marks and Spencer's Food as well. Bringing it into the UK, we had an attack by Clop ransomware ground on South Staffordshire Water in August 2022. They claimed they could manipulate the water treatment processes, although no physical disruption occurred. They also were not really sure who they were dealing with initially, because they thought they were dealing with Thames Water, and it only became apparent that they'd attacked South Staff's Water. But again, that highlighted that there were some very basic cybersecurity vulnerabilities that were exploited easily, such as remote access, such as weak passwords. And one of the things that I will go on about time and time again is actually how we really need to do the basics, and we need to do the basics often as well. So, so whether design or accident, ransomware has become a major threat to our industrial community. You're much more likely to face a ransomware attack on your industrial control systems, on your operational technology than anything else. And you need to build security controls in, and you need to be ready for a ransomware attack. And ultimately, our societies are dependent upon this as well. So I'm not going to spend a lot of time on this, otherwise we'll run out of time. But one of the things you can do is you can go and look at the ransomware attack on Royal Mail. I was in the cyber response team. I wasn't working for Royal Mail. I was working for another company, and it was on the Heathrow Worldwide Distribution Centre. Now, this occurred by a phishing attack and by somebody clicking on a phishing email on the wrong laptop that probably shouldn't have been connected to the industrial control environment. It probably shouldn't have had email on it, and that again is about cyber hygiene. There's the discussions with Lockbit, with the Russian ransomware gang, went on for a while, and what's I guess is unusual about these is that all of that was dumped out onto the internet, so you can read these conversations. Impact, it cost 10 million to recover. It was that Royal Mail Heathrow Worldwide Distribution Centre was dead in the water for 3 months. They had to go back to 1980s systems. They were dusting folders off shelves that they hadn't had a look at for procedures for a very long time. I mean, Royal Mail's parent company, it was a bad time to be hit anyway, because they reported a 6.5% year-on-year revenue drop of 22 million. But I think what was really significant was that there was overall a 5% decrease in international parcel deliveries. And the company did have a total loss of 319 million within the first half of 2023. And I'm not saying that that all of the cyber attack that occurred is attributable to that loss, because it was definitely difficult trading conditions. But what I'm pointing out, I guess, is that they lost customers. It was painful. It took a whole year to recover those systems. All of the systems in the Heathrow Worldwide Distribution Centre had to completely get rebuilt, and for a very long time they were on manual processes. So ransomware, top threat to industrial progresses, industrial operations. Dragos says in 2024 we saw 1,600 ransomware attacks and everything. As we've talked about that we're seeing collateral damage, and we're definitely seeing that ransomware is a particular sort of dominant threat, dangerous overall to the industrial environment. So let's talk about hacktivists. Hacktivists and ideological motivated groups are a rising threat to industrial systems. They are often state-aligned, and in my opinion, they are they're not necessarily directly controlled, but there's definitely a willingness to allow them to operate if there's not direct sponsorship. They are motivated by politics, ideology, patriotism. They used to be involved in defacements and doxing, as it's known, which is releasing confidential documents, but they've now pivoted. And there's a lot of targeting of critical infrastructure for disruption. The Russian war, as we've talked about, is very much a catalyst for it and everything. And we've got blurred lines overall. The thing about them as well is that you have very low sophistication when it comes to tactics, techniques, and procedures and their tools. They're not using anything other than just bad cyber hygiene. We use passwords to get into things, but they do sometimes deploy custom supplied malware. We saw that with Foxnet, where they wrote their own malware to take devices out in Moscow. UK relevance. There have been DDoS attacks on UK government and airport sites such as Heathrow in 2022, and the NCSC warns that critical national infrastructure must be able to defend against these state-aligned hacktivist groups. So it's really important. They are unpredictable, noisy, reckless. They often use deniable proxies for nation states. And they're a bit of a straddle, really, between crime, activism, and cyber warfare. So, I think overall your cyber defenses have got to really focus on, can I defend against hacktivists? Can I defend against ransomware? Am I ready for that kind of attack? And just talking about the simplicity, so this is Bauxite Cyber Avengers. They are Iranian, as I've said, and they target critical infrastructure. They primarily target Israel, but they targeted in 2023 multiple US-based water and wastewater systems. They used simply a tool which we can all go onto the internet called Shodan. It just identifies systems that are connected to the internet, and it can be used to identify easily accessible industrial control systems. In this case, it was used to identify Unitronics Vision Series PLCs. Those were connected to the internet with manufacturer default passwords built into them, and therefore it's at the level of a very low skilled and low sophisticated individual to be able to exploit these. But exploit them they did, and it caused they exploited it in Ireland. It caused a shut off of water supply for 2 days. So again, highlighting that fundamentally the basics of cyber hygiene, of doing things like changing and removing backdoors, changing passwords from manufacturing passwords, is fundamental to what we do. And some of the things that are significant, we've talked a little bit about these Ukrainian power attack, but we can see over time, increasingly, the number of attacks that are well known on industrial control systems. And this is by no means an exhaustive list. what's not on here are significant attacks such as Norsk Hydro that forced aluminium smelters into manual mode, 2020 attack on German hospital that caused a patient death, attacks on Ukrainian rail systems I know were thwarted, but there was a very significant attack to do with rail and mining equipment. But we are talking here ultimately around significant attacks that have caused damage overall, with the exception of the Iberian Peninsula attack, which we're going to jump into, which it was a massive power outage. It was claimed as a cyber attack, but it's very unlikely that it was a cyber attack. And certainly, Spanish government and other organizations have come out and explicitly said that it wasn't a cyber attack. But it's very interesting as a case study. So let's just jump into that as well. So 28th of April, lunchtime, we saw a massive power outage across Spain and Portugal. It also affected southern France as well as Morocco too. And there were effects, I understand, as well on some of the interconnectors into the UK as well. And we saw Spain's electricity generation plummet by 15 gigawatts, about 60% of the national demand. And if you work in the electricity sector, you'll realize that means you just simply cannot balance the network. You can't keep the frequency up on the network. And lights went out, traffic signals died, trains ground to a halt, the internet went down, all sorts of things happened as well. And there was a national emergency declared, cabinet meetings, emergency meetings. Authorities were sort of a little bit in the dark, literally and metaphorically. And they scrambled to assist people, such as people stuck in elevators in Madrid's main station, Atocha. There was absolute chaos. If you've seen the videos, overall, we remain dark. And initially, of course, we're going to ask questions: is this a cyber incident, and is this an attack by Russia? And certainly, the Spanish Prime Minister consulted NATO, and we were concerned overall about sabotage fears. But this could have been a cyber attack, and if it was a cyber attack, I think we would see some similar things occur. And some of the impacts that we saw was that there was ultimately 60 million people without electricity and power, which, it knocked out lighting, heating, cooling, water pumps. And it sent, the Spanish media was talking about being back into the 19th century. And one of the things that, for me, was a standout picture was people queuing up for trying to get access and buy wind-up radios, because that was the only way they could get information about what was going on and overall what was happening. So, it was very significant, and sadly, it also led to at least 8 deaths as well. And it was very significant insofar as that payment systems failed. We're a society that relies these days on electrical payments. You can't go and buy food. I saw a picture of a shop offering IOUs, for example. And if we saw a cyber attack, we definitely would see this kind of thing. It would probably be non-attributable. It would, by being non-attributable, by using hacktivist group, potentially not triggering an attack by NATO or NATO Article 5. So, in the case of the Iberian Peninsula attack, we saw No Name 57 claim a responsibility, a Russian hacktivist group, and also as well Dark Storm. So I think, to be honest, it's a stress test. But let's just talk very briefly around tools, techniques, and procedures, tactics as well of ransomware. And I just want you to have in mind that although some of these attacks appear to be quite sophisticated in nature, the most sophisticated cyber threat out there primarily uses spear phishing emails to get into systems. They first of all want to compromise their IT systems, and they are trying to exploit and They're trying to exploit the human and human behavior. One of the things that they've done before is they've sent out a Word attachment, and in the Word attachment was some interesting stuff to do with local football teams, and just trying to manipulate people in terms of like clicking on things. And once you've opened up the attachment, then everything's game off. But there's several steps that a sandworm has got to go through. APT 44 has got to go through before they can actually carry out an impact on your system. And keep in mind that all you have to do as defenders is detect this activity and be able to stop them before they get to the ability to carry out an impact. And as I said, very often an attack on OT is not an attack directly on OT, but is an attack via IT systems and everything. So let's just bring this to a bit of a close and think about some of the trends and threats and bring it to a conclusion. So first of all, we used to be able to separate nation state APTs, cyber criminals and hacktivists into nice, neat boxes, but we can't now. The lines are fading. State actors have used ransomware gangs as a cover. Cyber criminals are deploying techniques traditionally associated with espionage. Hacktivists even receive tools and support from governments. It makes attrition far more complex. Disruption to critical infrastructure may be the work of an intelligence agency or just simply a lone political actor. And the response path, therefore, isn't always clear. So NATO, for example, where's the threshold for triggering Article 5? And if you trigger Article 5, of course, it assumes that it's a nation state. But, it's a bit of a blurring of the line. The other thing as well is that they're living off the land. They're using known vulnerabilities. It's not complex. They're using things that are put in the public domain, contrary really to popular belief like Stuxnet, where it used a 0 day. Most attacks are not relying on 0 days. Even the most significant advanced threat groups are often exploiting weak passwords, exposed remote access and unpatched systems. The Oldsmar water breach, which you'll have seen on my timeline, is a good example. Attackers just use legacy remote desktop access, just a remote control access with no firewall. And it's really important, therefore, to have this good OT-IT hygiene gap and to make sure that you have a well-defined industrial DMZ. Most incidents are preventable with the basics of controls, but they really remain unaddressed in far too many industrial environments. And I'm a consultant. I get out there and I see it time and time again. And of course, we try to help people address those as well. Finally, don't ignore the supply chain and third-party risks. Threat actors increasingly target suppliers to reach their goal. The SolarWinds case through IT focus demonstrate how a single compromise can ripple across thousands of networks across the world. And we're seeing concerns around compromised PLC firmware, remote supplier platforms, and vendor VPNs. And as industrial systems become even more connected, these vectors are going to become more attractive, and supply chain compromise is no longer theoretical, it's proven and a potent attack. So overall we see reconnaissance and persistence in networks. We're increasingly seeing evidence that adversaries are sitting quietly observing rather than attacking. They're pre-positioning, and Volt Typhoon is an example where Chinese actors focused on gathering ICS data and maintaining long-term access rather than causing anything disruptive. And Russian attackers as well have historically embedded themselves in US energy networks for months at a time. Defence agencies in the UK advise that we assume key systems have already been probed, or even worse, are already compromised. And it's a bit of a silent battlefield preparation. And that makes threat hunting and continuous monitoring in OT environments essential. If you're not able to protect your environments because they're legacy, you must be able to monitor them. And overall as well, we see a bit of a physical and cyber impact convergence. We see where cyber attacks are deliberately synchronized with real world events. In Ukraine, cyber attacks on power grid have coincided with kinetic military operations. We saw that in Georgia many years ago as well. And even when incidents aren't proven to be cyber related, like the Iberian blackout, the suspicion alone heightens awareness. This convergence really means that critical infrastructure attacks are increasingly being used to send political messages, not just to gather intelligence or disrupt or anything. So while energy remains a primary target, attackers are expanding their reach. Manufacturing is, as I've said, the most frequently attacked sector. But we are seeing water systems both in the UK and globally as being attacked and vulnerable. Transportation is climbing fast, with rail, aviation, and ports seeing more incidents. Nozomi, one of our partners, placed transportation in the top 3 for newly reported ICS vulnerabilities. And it's overall, this should all be a wake-up call. In the UK, sectors like rail signalling and airport fuel systems need some vigilance, the same sort of vigilance that we would apply to power and water networks. So, really important that's going on here. So let's just bring the threat side of things to a conclusion and jump into one slide about how we go about solving it, and I can talk a bit more and answer questions. So context, we set the context. We talked about the strategic defense review is moving us to a war fighting readiness. There is a recognition that the people who operate operational technology, industrial control systems, probably don't have the capability right now to defend them. But the MOD has indicated that cyberspace is crucial as physical defense, that adversaries might strike at energy, transport, or water. And overall, we've got these 3 very clear threat actors, but we've talked about the blurring of line between these. So whilst I put these in nice, neat boxes, that's not currently how the world is. And from an engineering perspective, we must design systems so that safety and reliability now also hinge on robust cybersecurity practices. A system that is not cyber secure, that is not cyber resilient, is not a safe system. We have seen that. We've seen it way back in 2017 with the Trisus attack. A single compromised credential or unpatched interface can precipitate into cascading failure affecting millions. So the current threat environment for OT and ICS is the most dangerous I've ever seen it in my career. But awareness and readiness within the government is at our peak. We've got to, as industry, perhaps step up. So one very last slide, because I'm conscious of time. We've simplified things. We think that if you do 5 things and you do them really well, that actually you go a long way to secure your environments. I think you need to understand your risk, and you need to understand that from both a technical perspective, and also as well, there is a way of quantifying cyber risk in your organization from a financial perspective that tends to grab the attention of the board, which leads to the board making investments to be able to mitigate this. And that, of course, once you've grabbed that attention, you've assessed the risk, you then need to develop out a strategy to mitigate the risks down to a level that you think is acceptable. We talk about strengthening defenses. The fundamental, the quick wins is actually let's go out and identify bad practices, things where we haven't got segregation of networks, where we've got passwords that are being reused time and time again, where we've got default passwords still enabled. We've got to strengthen our defenses, but that's not enough. We also need to cultivate awareness. We need our people to start to understand what cyber threats are. We need to do cyber awareness training. We need to do exercising. We need to send out mock phishing emails, because that's often the way that attacks will come in. We've got to focus on keeping our people on the toes. Cybersecurity is never done. It is a continuous process. We need to monitor it, as we've talked about. But we also need to go through an iterative process and improve. So I'll skip through the rest of the slides on this. They're fundamentally the same things. And I will end there and say thank you for listening to me. Hopefully I have managed to talk about something and waffle about things that have been of interest to you, and I'll happily take some questions.
Thanks, Stephen. It was a very, very interesting presentation. I'd like to open up any questions to the people online.